This is Tech Math 2, and today we're going to be doing sections 11.7 and section 11.8. So in section 11.7, what we're going to find is if I have a vector, I can take that vector, so I got a vector v, I can find the x and the y components of that vector v. So the x component is going to be, so I have a vector v angle theta, cosine theta v sine theta. And if I have two vectors, let's say I've got vector a angle theta 1 and b angle theta 2, and I wanted to add them together, a vector a plus vector b, I could go and say the x components of a is a cosine theta, and a b is b sine theta, and the y components of a would be a sine theta, b sine theta, and clearly I got a mistake over there, so I better erase it real quick, and cosine theta. And then I can add these components, and I could add them and come up with a resultant vector, r in the x direction, r in the y direction. And then I could say, well, r is going to be the square root of rx squared plus ry squared. And the angle theta that the guy is going to be at is going to be the arctangent of the absolute value of ry over rx. And I recognize this as a reference angle, so if my answer is not in the first quadrant, I'm going to have to figure out what quadrant it is and get the right angle for it. Okay, so that is my overall plan. So with that, we will go to problem number 3. And for problem number 3, we have our vector is 135 miles per hour. And we're at an angle of 270 degrees, and we want to find the horizontal and vertical components. So v in the x direction is going to be 0, and v in the y direction is going to be minus 135 miles per hour. And you say, well, how did you get that? Well, I want 135 cosine 270. And I want 135 sine 270. And I put those in my calculator, and those are the answers that I got. And then the other thing we could do, if we wanted to, is we could take our calculator, and if we take our calculator and we go to mode, and we put it in rectangular mode, so the mode I want is a plus bi. That's what I'm looking for. And then I put in my calculator that I got 135 second function complex angle 270, and I hit the return button. The machine's going to tell me that I'm at minus 135 in the I direction. And that would be that minus 135 right there. And then it won't tell me that I have 0 in the other direction, in the x direction, because it's not going to put down the 0 for me. But my calculator will give me the x and the y components directly if I wanted to, if I didn't want to put in 13 sine, whatever. All right, now we're going to go to number 12. And I have Vx is 427 miles per hour, and Vy is 318 miles per hour. And I want to find the vector. All right, so v is the magnitude of v is going to be the square root of 427 squared plus 381 squared, and the angle is going to be the arctangent of the absolute value of the y component over the x component. I recognize those y and x components as being a first quadrant answer, positive, positive. So my reference angle will be the angle that I'm looking for, if I could spell reference. All right, now I'm ready to go, and I say square root of 427 squared plus 381 squared, close parentheses, and I find my magnitude is 572, and I go arctangent of 381 divided by 427, and I end up with 41.7 degrees. Now, I could have just as easily put my mode in polar mode. So I take my calculator and I change, in the mode thing, I change to R angle theta. Okay, and then I'm gonna enter in my calculator the x component, 427 plus 381i times I, enter, and it's going to tell me that my answer is 572 at an angle of 41.7. So my calculator will do this directly. I don't necessarily have to use the Pythagorean theorem in the arctangent, but I can. All right, so now we're looking at problem number 13. And problem number 13 says, in a series circuit containing a resistor and an inductor, the impedance of, let's see, in an inductor has an impedance of that. Okay, so I draw a picture and I say, oh, my inductor has an impedance going that way of 90 ohms, and and the phase angle is 20 degrees. Okay, so I'm coming this way, I got a phase angle of 20 degrees, and the inductor is 90 ohms. I want to find out what the resistor is. So find the resistance and the inductive reactance. Blah, blah, blah. Okay, so I got it drawn wrong. So I don't know the inductive reactance. The 90 degrees is the 90 ohms is my impedance. So impedance is 90 angle 20. Alright, so I know the angle's 20, I know the impedance is 90 to 2 significant digits. Okay, so the resistance is the x component of z. So that'd be 90 cosine 20. And the reactance is the y component of z, so that'd be 90 sine 20. And I just put that in my calculator, 90 times cosine 20, hope I'm in degrees, 84, we'll make it 80, yeah, we'll keep it as 84 ohms. I only have 2 significant digits, 84 ohms, 90 times sine 20, and I'll call it 31 ohms. Okay, number 14. A series circuit contains a resistor. Okay, so I've got a resistor that's sitting there at 85 ohms, and an inductive reactance, which is up there of 45 ohms, and I want to find the impedance. Okay, so the impedance is going to be square root of 85 squared plus 45 squared, and the phase angle is going to be the arctangent of the y component over the x component. And I see that my answer is a first quadrant answer, so that won't be any change in anything at all. So I'm going to enter 45 plus 85 times I, because I'm that type of guy. because my calculator is already in the right mode, and I end up with way to go. Totally destroyed the whole thing. Anyway, that's what happens. Way to go, computer. Take over. So as I was saying, the resistance is futile, and the inductive reactance is a little bit less, and I want to find that and that angle. Okay, so that's what I'm doing. All right, so I find that the impedance is 96. How many significant digits? Only two, 96 ohms, and the angle that I'm looking at is 62 degrees. No, it can't be 62 degrees. It can be 62 degrees. How can it be 62 degrees? Oh, I put it in wrong. Yeah, I put it in my calculator wrong. I will do it again. 85 plus 45 times I. All right, so the 96 stays the same, but the angle is 28 degrees. That's better. So it probably would have been better if I just did the math and not use my calculator to do it. Turning the page, and we look at number 15. Now, why are we doing 15 and 14? Oh, they're all electronics problems. I remember. A series circuit contains a resistor and a capacitive reactance. Okay, so my resistor is sitting there, and I've got 240 ohms, and I have a capacitive reactance sitting here, which is 140 ohms. And find the impedance and the phase angle. Okay, so the impedance is square root of 240 squared plus 140 squared, and the phase angle theta. And because arctangent gives you a third quadrant answer, we will just do that. We'll just find it, arctangent of minus 140 divided by 240, and then we'll say, well, that is the third quadrant answer, and that's all I'll write down. Okay, so I'll take my calculator and put in some numbers. And I end up with an impedance of 278 ohms. I only have two significant digits though, so I call it 280 ohms, and my angle is minus 30 degrees, which I don't particularly like. I'd sort of like to come around the other way, so I'm going to call it 330 degrees is my phase angle. But minus 30 might be closer to the truth. Well, they're the same number, so it doesn't really matter. All right, number 16 is next as we continue our path doing circuit analysis. One problem. The series circuit has a resistor and a capacitor, and the impedance is 110, and my angle is 49 degrees. Which makes no sense at all. Absolutely no sense at all. But anyway, that's what we got. So I got something there, and my impedance is going this way, and that's 49 degrees sitting there. And I want to find the resistance, and I want to find the capacitive reactance. All right, so the resistor is going to be, resistance is going to be, what? 110 cosine 49, and the capacitor reactance is 110 sine 49, because we wouldn't put in a negative number in there, would we? Because we wouldn't call it a negative capacitor reactance, we just say the capacitor reactance goes the other way. 110 times cosine 49. 72, and that's all we got. Just two significant digits, yeah, 72 ohms. 110 times sine 49, 83 ohms. And that's how we do that problem. Number 24. I've got multiple vectors. Okay, so what I'm going to do is I'm going to find the x component and the y component, add them together, and go from there. So I've got 5, 7, 6, 0, angle 90 degrees, which means this guy's 0, and this guy's 5, 7, 6, 0. So that was an easy one. The next guy, 3, 9, 4, 0 at 2, 0, 5. Okay, so I'm going to go 3, 9, 4, 0 times cosine 205. And I'm going to have minus 3, 5, 7, 1. Yeah, I can do that. And I can go 3, 9, 4, 0 times cosine, I just did that, times sine 205. And I can have minus 1665. All right, and then I can take the next guy, 6, 140, angle 150, and I can go 6140 times cosine 150, and come up with minus 5317, and I can go 6140 times sine 150, and come up with 3070. And then the last guy is 1230 angle 330. And okay, I'll just write down the y component 615 because I know it's half of that guy, so I don't have to put it in my calculator. 1230 times cosine 330 is going to be, actually it's going to be minus that. Going to be 1065. All right, so then we found the x and y components, so now we're going to add them together. So my resultant, okay, so I got that guy, minus 3571 minus 5317. So my x component minus 7823, and then I got 760 minus 1665 plus 3070 minus 615. Oh, that's going to be a positive number. Cool. 6550. All right, then I'm going to find r, square root of minus 7823 squared plus 6550 squared. Let's say square root of 7823 squared. I don't have to put the negative in because when I square it goes away anyway. 6550 squared. And so I got 10,020,203. We'll worry about how many significant digits I have later. My reference angle is going to be the arctangent of the absolute value of the y component divided by the x component. 6550, yeah, that was silly. Arctangent. 6550 divided by 7823.
You don't put the negative in there?
No, because I'm taking the absolute value. 39.9 degrees. And then I ask myself, what quadrant am I in? All right, well, I'm in the second quadrant because x is 0 and y is positive, right? So I'm positive y, negative x, so I'm over there. So in the second quadrant, my answer is going to be 180 minus the reference angle. So my final answer is going to be 180 minus the answer I just got in my calculator, 140 degrees. And then I said, so that was nice. I'm happy that that happened. What was I supposed to do anyway? Find the magnitudes of 3 significant digits in the angles to the nearest tenth of a degree. Oh, tenth of a degree? 0.0. 0.1. Then I can say, well, I could have done the same thing. I could have taken my calculator. I'm going to go back and I'm going to look at the mode. I'm already in polar mode. So I'm going to go and put in 5760 second function complex angle 90 plus 3940 second function complex angle 205 plus 6140 second function complex angle 150 plus 1230 second function complex angle 330. Hit the enter key, and my calculator would have told me that my answer was 10203 at an angle of 140.1. So my calculator got the exact same answer that I did, except that I'd have to mark it minus 0.1 significant digits, find the magnitudes of 3 significant digits. So as a final answer, I'd have to go 10 to 0, 0 and go that. So that would be my final answer because I can only have 3 significant digits in my magnitude. Okay, good enough? So do both things at the same time. Well, that leaves us section 11.8 to do. Maybe we can find some more electronic problems, who knows? So these are applications, which means I can do it any way I please. Okay, well, that's good. Well, we'll look through them real quick, and we find that the first page has no electronics problems on it. The second page has no electronics problems, and the third page has no electronics problems on it. All right, so that solves that question. And so we'll start at number 3. So that means all we have is physics problems. En route between 2 cities, an automobile travels due south 115 kilometers. Then 195 kilometers, 45 degrees west of south. West of south. And I'm going to go that way. 195. And we find that this is a 45 degree angle on this side. And then 45 kilometers west by boat. West by boat? What kind of dumb thing is that? Anyway, I think west by boat. 45. Find the displacement starting from start to end. So I want to find that vector. Now, yesterday we would have gone and used trig to do it, right? But this time all we're going to do is look at the x and y components. So I look at the x and y components, and I say I got minus 115 for the first guy, 0 for there. This guy is going to be minus 45, 0 for there. And now I just have to do a 195 sine and cosine of 45, and the sine and cosine of 45 is the same number, so I only have to do one of them. 195 times sine of 45 And I see that it's going to be negative in the x direction, 137, we'll call it 138, and negative in the y direction, minus 138. All right, so now I add up my numbers, and I have 3, 1 to carry, 5, 2, and I have 3, 1 to carry, 8, 1, and they're both negative. So I find my magnitude, square root of minus 183, which I'm not going to put the negative sign in my calculator because I'm squaring it, minus 253 squared, and square root of 183 squared plus 253 squared, and I get 312 kilometers. And then the angle I'm looking for is the arctangent of the absolute value of the y component divided by the other guy. Now this is a reference angle. I know my angle has to be in the third quadrant, so I'm going to worry about that later. Tangent 253 divided by 138, and I've got 54 degrees. And then I say, well, in the third quadrant, my answer is going to be 180 plus the reference angle. So my angle is going to be 1, 2, 3, 4 degrees. So my final answer is going to be 312 kilometers at an angle of 2, 3, 4 degrees. And then I go back and see what do I have for significant digits, and I have 3 significant digits everywhere, so I will keep my 3 significant digits in my final answer. Now I could have just as easily put it in my calculator. I could have gone 115 second function complex angle 270 plus 190 second function complex angle 225 plus 45 second function complex angle 180 equals, and my calculator would have told me that the correct answer is 312 kilometers at an angle of minus 126. And then if I go 360 minus 126, I get 4, 3, 2. I end up with the same thing that I had there. So I could have just put it in my calculator and got the answer. I just goofing off until the end of the hour probably. Number 8. Questions about that? Make your calculator do it. That's what you paid the 20 bucks for. 8. Find the angle between 2 original displacements if the magnitude of the resultant distance is 7.5 miles. Okay, find the angle between 2 original displacements. Okay, so I got this guy, there's an original displacement, and here's another original displacement, and the angle, and this guy here, the resultant is 7.5 miles. Well, exactly how many answers do you think we can have to this problem? Oh, given an infinite number. But if you look on top in exercise 5 through 8, the displacements have magnitudes 10 and 15. All right. So So if one of these guys is 10 and the other guy is 15 and this guy here is 7.5, then what is this angle here, A? Well, I have a triangle side, 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 so that means I'm using I'm using the law of cosines, right? So 15 squared is equal to 10 squared plus 7.5 squared plus minus 2 times 10 times 7.5 times the cosine of A. All right. So A is going to be equal to the arc cosine of 15 squared minus 10 squared minus 7.5 squared divided by minus 2 times 10 times 7.5. And now it's just a matter of, can I put it in my calculator? Now, if I didn't recognize I was going to use the law of cosines, I could have been looking at that problem for a very long time. Extremely long. Okay, arc cosine, parentheses, 15 squared minus 10 squared minus 7.5 squared, close parentheses, divided by, parentheses, minus 2 times 10 times 7.5, close parentheses, another close parentheses, hit the enter key, and the angle is 117 degrees. Oh, Did I do that wrong? I think I did that wrong. Find the angle between the two original displacements. Oh, bummer. Tell me that the angle isn't there. All right, so I want this angle A. Okay, I want that angle A. All right, so this has to be 7.5 squared. This has to be 15 squared. This has to be 15. All right, so now I've got, this has to be 7.5, that has to be 15, and this has to be 15. Anyway, so much for entering in the calculator wrong. Arc cosine, 7.5 squared minus 10 squared minus 15 squared. Well, isn't that really good? I didn't put parentheses up there. Parentheses, second function, insert 7. That's good. So I don't have to rewrite everything. Close parentheses divided by parentheses minus 2 times 10 times 15, close parentheses, again, boom. So now I got 78.7 degrees, and well, I have 3 significant digits, so I can have 3 significant digits in my angle. Anyway, almost got that one wrong. Number 8. Number 15. Oh, turn the page too quick. A plane is heading 35 degrees west of north. There's my XY plane. My plane is flying that way, and this is 35 degrees west of north at 315 kilometers per hour. The wind is blowing from the west. Okay, so the wind is blowing that way, and the wind is doing 50 kilometers per hour. Find the plane's course and speed. Okay, so what I'm going to do is I'm going to find the x direction and the y direction of both of these vectors. So the wind is going to be 0 in the y direction and 50, positive 50. And the plane is going to be 315 times cosine 125. Going to be minus 180.7. Well, I got to come this way. So 90 plus 35, 125. Yeah. And then I need 315 times sine of 125. Yeah, I was hiding that one. 258. Okay, so I'm going to add them together. I'm going to get minus 130.7 and 258. So the plane magnitude P square root of 130.7 squared plus 258 squared, and then the angle going to be the arctangent of the absolute value 258 divided by 130.7, and that's a reference angle. When I get done, I want to know it as a second quadrant angle, so I'd have to write it as a second quadrant angle. Okay, so now I've set up the problem, and now I'm going to put it in my calculator as 50 plus, actually 50 minus, 50 minus, no, 50, yeah, 50 minus. I'm not going to do that either. All right, I'm going to clear that out. I'm going to go 50 second function complex angle 0 plus 350 second function complex angle 125. And my calculator gives me a syntax error. Stupid calculator anyway. Way to go. Just thank you very much, calculator, for your concern. But anyway, back to doing it manually because my calculator wants to be stupid. Give me an error. I think there's a memory function here that I haven't dealt with before. 130.7 squared plus 258 squared, close parentheses. So it looks like the plane's going 289 kilometers per hour, and our tangent 258 divided by 130.7 of 63 degrees as a reference angle. Gee, that doesn't make any sense, does it? So 180 minus 63 gives me 117 degrees. Okay, well, I guess that makes sense. 117 degrees. So the wind's not blowing me too far off course, but it is blowing me a little bit off course. Okay. So did I waste enough time on that one? 15. Not quite. 24. Find the vector sum. 24. All right. So I got something going that way, something going this way, something going that way. And this is 1450, and that's 975, and this one's 825, and they're all in pounds. And then I got angles sitting around here. Okay, so this guy's going north, and I got 50 degrees going that way, and I got 150 degrees going this way. Okay, so that being the case, I have 825 angle 90. I have 975 angle 40 when I put all these guys in standard position. And then I got 1450 angle 240. Okay, so those are the angles that I have. And then I want to find their x and the y component of each of them and add them together. All right, so 0, 8, 2, 5. And 750 times the cosine of 40. And I get a 975 times sine 40. And I get a 627. And then I go 1450 times cosine 240. And I get a minus 725. And 1450 times sine 240. And I'd get a minus 1256. And then I'd add them together. Well, I'm going to add them together. 2, 2, 2, 2. And I add them together. 825 plus 627 minus 1256. And I get a 196. So my resultant magnitude, square root of 22 squared plus 196 squared. And I'm pretty sure that's going to be 196. What do you think? No, 197. Lucky guess, 197. And then I see my answer is going to be a first quadrant answer, so that's a good thing. So theta is going to be the arctangent of the absolute value, which I really don't need, 196 divided by 22. And throw it over there. Arctangent, 196 divided by 22. 83.5, but I don't think, yeah, we have 3 significant digits. Okay, so we can go 83.6. 83.6 degrees. And again, I wouldn't necessarily have to do that if I just put it in my calculator. Okay, now we're going to do problem number 33, because it's the only electronics problem in this section. Number 33. What makes an electronics problem anyway? Oh, it says Bob's Electronics. All right, so I got some stuff that was mal-designed. All right, so I got that. And I got something coming down that way, something coming down this way, holding on to a sign. And the sign is 457 pounds. All right, so that's how big the sign is. All right, and I got 50 degrees over here, and I got 45 degrees over there. Now, is the sign moving? That's the key issue. So, if the sign is moving and is about to yank off the building, then we can't do anything about it. But if the sign is stationary and not moving back and forth, then this guy's x component has to equal that guy's x component. And they have to be opposite directions, otherwise the sign would be moving one way or the other. Okay, so that would be the case. And the y component, so the y component over here has to be carrying part of the sine, and the y component of this guy has to be carrying part of the sine. And when I add them together, it has to be 4, 7, 5. Okay, so what does that mean? Okay, so the cosine, okay, we're going to call this tension 1. No, we're not. We're going to call this tension 2. Tension 2, tension 1. Okay, so I look at this guy. The cosine component is tension 2 cosine 50. And that has to equal tension 1 cosine 45. They have to be the same. Okay. And I know that tension 2 sine 50 has to equal plus tension 1 sine 45 has to equal 475. Okay, so now I have two equations, two unknowns, and I'm ready to solve them. How come I wrote down cosine twice there? Anybody know? All right, so I've got the cosine of 50, cosine of 50. So I've got 0.642 T2 minus, and then I need the cosine of 45, cosine 45. So 0.707 T1 minus 0.642 T2 has to be 0. That's the first equation. My second equation says that the sine of 50, which I don't know yet, sine of 50, that's cool. I put in 51 in my calculator. Sine of 50 plus 0.766 T2 has to equal sine of 45. Okay, so that's 0.707 T1, because the sine of 45 and the cosine of 45 is the same number. Okay, well now I have two equations, two unknowns that I can solve, and because I only have a minute to go in the class, I propose we just put them in a calculator and solve it. So second function, solve a system of equations 2 by 2, and my x component 0.707, my y component minus 0.642, okay, and is equal to 0. All right, excellent. The next guy, 0.707, and this is going to be a plus sign, so I'll put a plus sign. 0.766, enter, and I'm going to be 475. All right, so I'm going to solve it, and I'm going to find that T1 is equal to 370 pounds, and T2 is equal to, now, you got to be kidding me, 118750 divided by 427. Why did it do that? All right, well, I know how to do that. 118750 divided by 727, whatever the number is. All right, so 278 pounds. Why would it leave it as an improper fraction like that? That doesn't make any sense. Way to go, calculator. Anyway, that's how I would do that problem. All right, any questions? Any thoughts? Anybody have a